Hello students, you are watching ICSE Mathematics and today we will start chapter number 7 Ratio and Proportion Standard 10 ICSE Mathematics. Okay, now let us begin with the definition. What is ratio first of all? Okay, so ratio. Okay, let A and B be two quantities of same kind and in same unit. Okay, then A is to B is, or then the fraction A upon B then the fraction A upon B is called the ratio and is expressed as A is to B, and it is read as A is to B. Clear? So in short, what you have understood over here, that a ratio is a fraction. Yes or no? Ratio of two quantities of same kind and having same unit is a fraction A upon B, which is written as A is to. Clear? Now, okay, in ratio A is to B, A is called the first term and B is called the second term. Okay. First term or A is also called the antecedent and B is also called the consequent. Clear? So A is called either the first term or it is called the antecedent, and B is either called the second term or it is called the consequent. Okay, now an important property we will see for ratios. An important property of ratio. Okay, what is that? If both the first term and the second term of a given ratio are multiplied by a non-zero are multiplied or divided by a non-zero constant, say m, then the value or then the ratio remains unchanged. How? So obviously we know that A upon B, okay, that is the given ratio. Now if you are multiplying both the first term, that is A, and the second term, that is B, by a non-zero constant, say M, then MA upon MB, okay, obviously it is very clear that A upon B is equals to MA upon MB, or if you are dividing A and B both by M, then in that case we have A upon M upon B upon M, B upon M, okay, this ratio is equal to A upon B. Clear? Okay, so I hope that you have understood this property that A upon B is equals to MA upon MB, or A upon B is equals to A by M upon B by M. So if you multiply both the terms of a given ratio by non-zero constant, or if you divide both the terms by non-zero constant M, the ratio remains same. Clear? So it is a constant always, remember. Clear? Okay, now writing the ratio in the lowest term, writing the given ratio in its lowest term. Okay, in order to convert a given ratio in its lowest term, we divide both the terms of a given ratio by their HCF. Okay, by their HCF. Clear? For example, suppose we are given a ratio 8 8 upon 12. Clear? Now, in order to write in the simplest form, obviously we can reduce both the numerator and the denominator by the HCF. So HCF of 8 and 12 is 4. So 8 upon 12 and okay, 8 divided by 8 divided by 4 upon 12 divided by 4, which again will give you okay 2 upon 3. Clear? So this is the simplified form which can be written as 2 is to 3. Clear? So the ratio 8 is to 12 is a fraction given by 8 by 12 and which is simplified as 8 divided by 4, 12 divided by 4, 2 upon 3 or 2 is to 3. Okay, so in this way you can reduce to the lowest term. Yes or no? Yeah, reducing in the lowest term means we look at the first and the second term of the ratio 2 is to 3. The HCF of both the first and the second term must be 1. Clear? Okay, now comparison. Okay, suppose if ratio the ratio terms are in fraction, then what we are doing, suppose if the ratio terms are in fraction, then okay, we multiply each term by the LCM of, if the ratio terms are in fraction, that is first and second term both are fraction, then we'll multiply each term by the LCM of their denominators, by the LCM of their denominators, okay, and convert into whole numbers, okay, and then as usual we are going to simplify. Clear? So in this way you can simplify the complex ratios or complex fractions. Now comparison between two ratios. Okay, now how will you compare the two ratios? Okay, for that, number one, suppose if A is to B is greater than C is to D, okay, it double implies So A upon B is greater than C upon D, okay, which again double implies AD is greater than BC. Okay. Similarly, number 2, if A is to B is equal to C is to D, it double implies A upon B equal to C upon D, which double implies AD is equal to BC, and A is to B is less than C, C is to D. Okay, double implies A upon B equal to, sorry, is less than C upon D, double implies AD is less than AD is less than BC. Clear? So this is the comparison between the two ratios. If A is to B is greater than C is to D, then we write AD greater than BC. For A is to B is equal to C is to D, we will write AD is equal to BC. And for A is to B less than C is to D, we will write AD is less than BC. Clear? Okay, now let us switch on to the next topic, that is proportion. What is proportion? Okay, so for non-zero quantities A, B, C and D are said to be, okay, but before that, what is proportion? Let us see. Proportion is a statement of equality of two ratios. What is proportion? Proportion is a statement of equality of two ratios. Clear? So for non zero quantities A, B, C and D are said to be in proportion if ratio A is to B is equal to ratio C is to D, and we write A is to B as C is to D. Clear? And this is read as A is to B as C is to D. Clear? Okay, so here A, B, C and D are called the first, second, third and the fourth terms respectively. Here A, B, C and D are called first, second, third and fourth terms respectively. Okay. Further, certain points we will remember also. Point number 1, okay, here D is called the fourth proportional to A, B and C. Okay, similarly B and C are called means or mean proportionals, and A and D are called extremes. Okay, B and C are called means, and C and D, A and D are called extremes. And number 3, product of means is equal to product of extremes. Okay, that is for A is to B as C is to D, A multiplied by D is equal to B multiplied by C. Yes or no? Product of extremes is equals to product of means. This is an important result which you will remember here. Okay, so let us again go through the 3 points. D is called the fourth proportional to A, B and C. B and C are called means, and A and D are called extremes. and further product of means is equal to product of extremes. Clear? Okay, now continued proportion and mean proportion we will see one by one. Continued proportion. Okay, what is this continued proportion? So A, the quantities A, B, C, D, E, F, etc. are in continued proportion if A upon B is equal to B yes, B upon C is equal to C upon D is equal to D upon E is equal to E upon F. Clear? So if this condition A upon B is equals to B upon C is equal to C upon D is equals to D upon E is equals to E upon F is satisfied, then we can say that the quantities A, B, C, D, E, F are in continued proportion. Now what is mean proportion? Let us see. Mean proportion. Okay. Uh, let A, B, and C are three non-zero quantities such that A upon B is equal to B upon C. Okay, then okay, this implies okay, this double implies AC is equal to B square. Okay, which implies B is equal to square root of AC. Yes or no? B is equal to square root of AC. Okay, now here B is called, here B is called the mean proportion. Is it clear? So if A, B, C are the three non-zero quantities such that A is to B is equal to B is to C, then AC is equal to B square or B is equal to square root of AC. Okay, so here B is called the mean proportion. Okay, between A and C. Clear? So I hope you have understood what is mean proportional clearly. Okay, and what is third proportion? That also we should see. Okay, now an important property of proportions. An important property. Okay, if we have A upon B equal to C upon D equal to, okay, A upon B equal to C upon D equal to E upon F equal to K, then each ratio is equal to A plus C plus E upon B plus D plus F. Okay, so you will remember that each ratio is given. Each ratio is given by the formula sum of antecedents upon sum of consequents. Clear? So this is the formula to find each ratio. Clear? Okay, now some important results we will see. Results on proportions. Okay, number one. Okay, ratio if A upon B is equal to C upon D, okay, will imply B upon A, B upon A equal to D upon C. Okay, now this property is called invertendo. What is it called? Invertendo. Okay, here we are. If ratio A upon B is equal to C upon D, then B upon A will be equal to D upon C, which is obvious. Clear? Number two, if we have A upon B equal to C upon D, okay, which will double imply A upon C A upon C is equal to B upon D. Now this property is called alternando. Okay, notice that the positions of B and C are interchanged. Clear? Okay, now if A upon B is equal to C upon D, double implies double implies A plus B upon B is equal to C plus D upon D. This property is called componendo. Okay, here we are adding both the first and the second terms in the numerator while we keep the denominators unchanged. There. Okay, now number 4. This was number 3. Okay, number 4. If we have A upon B equal to C upon D, okay, which will double imply A minus B upon B is equal to C minus D upon D. Okay, this property is called dividendo. Okay, notice that we are subtracting first term minus second term. This difference we are taking in the numerator while the denominator is again kept unchanged. Okay, now next property, if A upon B is equal to C upon D, then we have A plus B upon A minus B is equal to C plus D upon C minus D. Now this property is called componendo and dividendo. Clear? Notice that we are adding both the terms in numerator and in the denominator we are taking the difference. Clear? So we are going to use these all the results in solving the exercise. Okay, remember the result, each ratio is given by sum of antecedents upon sum of consequence, or sum of numerators upon sum of denominators. In simple words you can remember. Clear? Before that we have seen mean proportion. If A, B and C are three non-zero quantities, okay, such that A by B is equal to B by C, then B square is equal to AC. That will imply B is equal to square root of AC. Here B is called the mean proportion between A and C. Okay, now third proportion. Let us see what is third proportional. Third proportional. Okay, third proportional. Let A, B and C be three non-zero terms in continued proportion. Okay, then C is called the third proportional to A and B. Yes or no? Clear? If A, B and C are in continued proportion, then C is called the third proportional to A and B, and C is the fourth proportional to A, B, and B. Here A, B, and B. Yes or no? So in this case, B will be the mean proportional as we have seen earlier. Clear? So with this explanation part of this chapter is over. Okay, now in the next video we will start with the exercise. Since this year the exercise of the ratio portion is omitted, so we are going to solve the exercises which are based on the proportion and its properties. Okay, take care and thank you very much.